Assalamualaikum and hi Dr. Naif. My name is Daniel Zambri and today we from Group 5 will present our project.
Okay, for our group members, we consist of 6 members. So the first member of the group is Daniel Zambri, following by Muhammad Akram Radi and myself, Nitisaran. And fourth member is Lee Chi Hui and Chai Sin Yan, and lastly Go Jia Singh.
So for the introduction is the smart shopping cart system revolutionized retail with sensors, microcontrollers, cloud platforms and communication modules, enhancing shopping efficiency and security. Utilizing RFID tags, which is never made before in any shopping cart system, it offers real-time inventory and sales tracking, addressing inefficiencies at checkout and improving inventory management for a seamless, innovative shopping experience.
Assalamualaikum. My name is Muhammad Akram Basmail and I'm going to present the flowchart for methodology. This figure shows the initialization of microcontroller before any operation. The microcontroller first initialize the MHR3522 RFID reader and check the communication status. The communication status starts by checking the connectivity of Wi-Fi and the connection to the Blink cloud server. After successful connected to the cloud server, the microcontroller retrieves the latest reports on sale of the card and upload to the Blink cloud server. This part shows how the microcontroller writes the data to the tag. After the enemy has chosen to write data, the RFID MHR3522 reader will change its state to write state. Enemy has to choose which product ID has to write to the tag, then only scan the tag to complete the write data function. After writing the data, the stream monitor will show the status of execution. This part shows how the microcontroller read the data from the tag. After the enemy has chosen to read data, the RFID MHR3522 reader will change its state to read state, which means it is available for user to use the card. The user has to scan the product tag to the RFID reader, and it will retrieve the product ID from the tag. Once the product ID is retrieved, the microcontroller will send request to Firebase database to search for card for some same product. If the product existed, it means the product is already added to the cart, so it will just increase the quantity. If the product is not found, it will retrieve the details from the Firebase the database of product using the product ID and add to the cart. The user can see immediate updates on the mobile optimized web application, which shows the updates in the cart. This part shows the final process, which is the checkout the cart. The user chooses to check out, edit the quantity or empty the cart in the web application. If the user chooses to check out, then the user will move to the payment section. Once the payment succeeds, the cart will be emptied and a transaction history will be added to the Firebase database. If the user chooses to empty the cart in the database will be emptied.
Thank you, my friend, for your presentation just now. So we move on to the hardware components. So the hardware components involved or included in this project is RFID sensor, the RFID tag, microcontroller, communication module, and these are the modules mentioned. And the purpose for RFID sensors are to read RFID tags attached to products. RFID tag is to identify and track items in the shopping cart. Microcontroller to control the system and process sensor data. SP1 communication module, SPI communication module for facilitate communication between microcontroller and sensors, and Wi-Fi for facilitates the communication between the microcontroller to the platforms. For the software components, the software component used is Combination Protocol, IDE, which is Integrated Development Environment, Cloud Platform, and the programming language. So the communication protocol is SPI that facilitates communication between the microcontroller and sensors, Wi-Fi to establish the access to the internet, and HTTP to transfer the data over the internet. For IDE, Arduino IDE is used to write, upload, and debug the firmware code for the microcontroller. For the cloud platform, Blink and Firebase is for real-time data sync and for device management and remote monitoring. And for programming language, we use C. and C++ for writing firmware code for the microcontroller and managing sensor data processing and communication. Meanwhile, HTML, CSS, and JavaScript for writing user interface for the shopping cart.
My name is Che Jin, and I will be presenting about the design and analysis of the smart shopping cart system. So this is a breadboard diagram for the connection between Wemos D1R1 board and the RC522 RFID reader. So we will start off with the D7 pin. The D7 pin on the Wemos D1R1 is connected to the MOSI pin on the RC522. This will enable the data transmission from the microcontroller to the sensor. Next, the D6 pin is connected to the MISO pin, allowing data to be sent back to the microcontroller. And the D5 pin is connected to the SCK pin for clock signal synchronization. Next, the D4 pin is connected to the SDA or S5 pin, serving as the chip select line. The D0 pin is connected to the ISD pin to reset the sensor when needed. Additionally, the ground pin on the Wemos D1R1 is connected to the ground pin on the RC522 to establish a common ground. And the 3.3 volt pin is connected to the 3.3 volt pin on the IC522 to provide power. And lastly, the IRQ pin on the RC522 is less unconnected as it is optional for this project. This setup ensures proper communication and functionality between the Wemos D1R1 board and the RC522 RFID reader. And now I will be passing to my friend Jiaxing to explain further on the sensor accuracy and also the data visualization. Thank you.
I am Goja Singh. Next, I will present about the sensor accuracy. There are a total of 7 scenarios have been conducted to test the sensor accuracy. The first scenario is distance between sensor and RFID tag. The optimal range is within 3 centimeters. Accuracy decreased significantly beyond this optimal range. Second scenario is angle of interaction. The best performance is when the RFID tag is perpendicular to the sensor. The acute angle or obtuse angle reduces the detection accuracy. Scenario 3 is placement of product. It is encouraged to individual scanning to avoid the detection issues. Multiple products close together can lead to reading failure. Scenario 4 is data restoration upon reconnection. Successful restoration of data upon reconnection. This is to ensure no data loss and maintaining integrity. The fifth scenario is CRUD operation in the apps. Create, read, update, and delete operation are effective. This is to enhance user control and usability. The sixth scenario is refresh rate of the shopping cart. The shopping cart will refresh every 5 seconds. This is to provide an up-to-date information without significant delay. The seventh scenario is bot operation frequency. There are one operation per second. The observation is to reduce timely data processing and communication. Data visualization. For the data collection, we have used Firebase as a database to capture all transactions made by the user. The database updates every second. For the visualization tool, we have used the Blink application to view the real-time graph. For the graph above, we can see that the y-axis shows the amount spent in currency and x-axis shows the time. For the time around 8:54, they have a transaction occur over 100. The spending report has benefit to the user such as user engagement. It helps users monitor and control their spending. Furthermore, it also has data accuracy. It reflects accurate transaction data in real time. And the last one is usability. It enhances user experience by providing immediate feedback. That's all for me, and I will welcome my teammates to continue. Thank you.
Okay, as for the conclusion, the smart shopping cart system represents a significant advancement in the retail sector, utilizing cutting edge technologies to enhance consumer experience and operational efficiency. By integrating RFID technology, it enables real time item tracking, and also reduces the checkout times and improves inventory accuracy. Leveraging cloud platforms, this system is highly adaptable, promising substantial improvements in customer satisfaction and operational efficiency. This innovative solution not only meets but exceeds current retail industry demand, offering merchants a competitive advantage and delivering unmatched convenience to customers. Ultimately, its deployment is poised to revolutionize retail operations and setting new standards for productivity and customer interaction.
That's all from us. Thank you very much.